Hello, Nick, and also everyone. Because Nick met a situation in which the independent variable is categorical. That's no problem. But the dependent variable is also categorical. So in that situation, both the IV and DV are categorical. So how to analyze those data? So I didn't really talk about how to analyze the data if the independent variable is categorical. So today I'm going to talk about how to analyze the data if the DV, the dependent variable, is categorical. So I found a new data set that can help me to illustrate how to analyze those kind of data. So if both IV and DV are categorical, we should use chi-square test. So with the chi-square test, you can test whether there is a association between two variables if the two variables are all both categorical variables. So we can know about this data a little bit. So this data is about the records that how many people survived from the Titanic event, the Titanic incident. So in history, there was a ship called the Titanic, and it sank to the Atlantic, and some people survived, some people didn't survive. So here's a data set that record the situation. So we can see this variable is the DV. We can see it as a DV that survived. So it's a categorical variable. So 0 means died and 1 means survived. So there are only two categories, died or survived. And also the IV is a residence. That's the country of residence of each person on that ship. So there are three categories. 0 means American, 1 means British, and the second is all other countries or country of residence. So all the both the two variables are categorical variables. We want to see whether the two variables have connections or have associations. So it means that whether the country of residence influence whether each person survived or not. So we can do a chi-square test to analyze that. So the data has been coded, so we can directly analyze it. So first you click analyze, and you put the mouse on descriptive statistics. So that's the second option. And you go to crosstabs here, crosstabs, and click it. So here there's a box called row and there's a box called column. So you probably want to put the independent variable into rows and put the dependent variable into columns. And then wait a second, you need to set this up. You need to click the second button, statistics, and check the chi-square button. So you need to check this so it shows the chi-square test results, and just click continue, and you go click cells, and you click this expected counts. So I'll tell you later what this means. And also you click this one, the percentages of row, and click continue, and click OK. Okay, it's working. Okay, so here's the output. You can see here's the cross tabulation or the percentage for each category. So we can see this part at first. This part is a total count. You can see there are 1,309 people in this data set, and 500 of them survived, but 809 people died. So that's overall situation. So like about 800 people died and 500 people survived out of 1,300 people. That's actual count. And the second row here is expected count. So expected count is same with actual count here in total. And the third row is percentage within country of residence. You can, what does that mean? It means that if this number is divided by this number here, so the people, the number of people who died is divided by the total number of people. That is this percentage, 61.8%. Means that 61.8% of people died in that accident. How do we calculate that? The number of people died divided by the total number. And this is the percentage that for the people who survived. So 500 divided by 1,309, that's 0.382. So that percentage is 38.2%. So that's the overall situation. So more people died and less people survived. And we can see a number here in this part. So all this data are for the American people. So you can see 113 people died. 113 American people died. And 145 American people survived. And the total number of American people on this ship was 258 people. So this percentage, you can see how many percent of people, American people, died, and how many percent of American people survived. So you can see that's 43.8 and 43.8 people died, and 56.2 people, American people, survived, and the total percent is 100% of course. So you can see this percentage is a little bit lower than this percentage. So if you are American, you are less likely to die. That's what the number indicates. So this number, the percentage of survived, is much higher than the percentage of survived. So, okay, I'll say it again. So the percentage of people, American people, survived is higher than the percentage of the people who survived, no matter what country you are from. So it means like if you are American, or Americans are less likely to die and more likely to survive. So there is a kind of some kind of association between country of residence and the chance of surviving. Okay, so you can see the percentages are weird here. And on the second row, there are expected counts. So what does that mean? So where are these numbers from? So actually, there are 258 people, American people on this ship. And if you use this number to multiply this percentage, that's this number. So expected counts means that based on the percentages from the total population, from the total, you can get how many American people died. Like I will say it again. So there are this many American people, right? To more than 200, and so we can use the percentage here to estimate, to expect how many American people would die if the chance of dying is this one, 61.8%. So if you use this number, multiply this number, and the outcome is this number. So that's where the expected count comes from. And also it's true for survived. If you use this number to multiply this number, if that out of 258 people, and the chance to survive is 38.2%. So there are there will be 98.5 people survived. So that's on the second row. This is expected count. On the first row, that's actual count. So you can see expected count is different from actual count. So why they are different? Because the chances to die in different groups are different. So if you in the American group, the chances to die is less, and the chances to survive is higher, right? You can see for the British, the expected counts of the died people are 186, but the actual count is 206. That means that I expect that among the British people, there are less 200 people would die, but actually there are more than 200 people who died. So the percentage of the died people are higher than the overall percentage. Okay, so this sounds like for the British, they're more likely to die, but for American people, they are less likely to die. So that's what we can see from this table, and then we need to look at the result of the chi-square test. That's simple, right? So look at the first row only. The Pearson chi-square. That's the value of the Pearson chi-square value. Pearson chi-square, that's 44. So what does that mean? Doesn't mean anything if you do not look at the significance value. The significance value is 0.00. Means that it's highly significant, right? So it means that the results, there is association between country of residence and whether people survived. So if this number is smaller than 0.05, it means that result is significant, means that the two variables has connection, two categorical variables has connection. And based on this table, you can see like who will have higher chance to die and who will have less chance to die, or who will have higher chance to survive and who will have less chance to survive. And also you can can check out this document. It's a PDF file online, and it tells you how to do the chi-square using SPSS. So yeah, here are the description of that tells you how to do the chi-square test, and also tells you how to do it, and really specific. Tells you what to set up, and you can see the results. And also tells you how to report the chi-square results. Okay. And also tells you how to draw a graph. So how to do that? How to draw a graph for the chi-square test? Okay, let me see. So if you want to draw a graph, you need to go to graphs, not analysis, not analyze. Go to graphs and go to Lexi dialogs and go to bar. And the default setting is simple bar chart. And you need to switch to stacked bar chart and click define. And let's see, you can put the IV into here, category axis. So it tells the machine that on the x-axis, they'll list all the categories for the IV. And you put the DV to here to define stack spike. And let's see. Click OK. Well, they will create a graph for you. You can see this is country of residence. This is IV, American, British, and other. And on here, that's the DV. There in the DV there are two. There are two categories. So you can see here for American people, looks like there are more people who survived and less people died. But for the British, there are less people survived and more people died. And for all others, there are less people survived and more people died. So you can see from the graph that the percentage of dying and the percentage of being survived are different among different groups. Okay, so for Nick's case, the IV has 2 levels, and the DV has 3 levels. It's a little bit different from this case, but I think the logic is the same. So only the number of levels for each variable are different. So in this case, the IV has 3 levels and the DV has 2 levels. And in this case, Nick's case, the IV has 2 levels and the DV has 3 levels, but it's fine, I think. So Nick, if you have any questions, you can ask me still. All right, bye-bye.